Here we're going to try and take the partial derivatives of a slightly more complicated function. So here we're going to have to use both the product rule and the chain rule. So let's start with the x derivative, df dx. So first of all, I need to split the function up into a u and a v. So first of all, I calculate u dv dx. So we have u, 5xy cubed, and then dv dx, derivative of cos is minus sine. But now I also need to calculate v du dx. So we'll have v cos x plus y, and du dx, that's just 5y cubed. The next thing to calculate is df dy. And now that's going to be u dv dy plus v du dy. So u, 5xy cubed, and dv dy again is going to be minus sine x plus y. Next I need v du dy, so that's cos x plus y, that's v, and du dy is going to be 15xy squared. So the next thing to do is to look at higher order derivatives. So we're going to calculate d2f dx squared. So first of all, we'll use the product rule on the first part of df dx. So that's going to be u, that's 5xy cubed, times dv dx, that's going to be cos x plus y. And now second term, so we keep the minus sign. And now we differentiate 5xy cubed with respect to x, so that's just 5y cubed. Now we need to differentiate the second term, 5y cubed cos x plus y. No need to use a product rule here because the first term doesn't involve an x. So that just gives me 5y cubed stays where it is, and the differential of cos is minus sine. Now I've got two terms here I can combine to make the answer slightly easier. So this is going to be minus 5 xy cubed cos x plus y minus 10 y cubed sine x plus y. So that's my first second derivative done. Now I need to calculate the cross derivative. So that's going to be d2f dy dx. So that's d by dy of df dx. And we'll just remind ourselves what df dx is. So that's d by dy of minus 5 xy cubed sine x plus y plus 5y cubed cos x plus y. And this time I need to apply the product rule to both terms because both factors of both terms have y's in them. So we'll start with the first term. So that gets me minus 5 xy cubed So that's u, and then dv dx gets me cos x plus y. And now I need to do v du dx. So we'll keep the sign. And now we calculate du dy. So that's going to give me minus 15 xy squared. So that's the first term differentiated. Now I need to differentiate the second term with respect to y, and again I'm going to use a product rule. So first of all, u, that's 5y cubed, dv dx, cos differentiates to minus sine, so that's minus sine x plus y, and now v, cos x plus y, du dy, 5y cubed differentiates to 15y squared. So that's my second cross derivative done. And there's no real nice way of tidying this up, so I'm just going to leave it as it is. So next we'll look at the second derivatives based on df dy. So first thing we want to calculate is d2f dy squared, and that's going to be d by dy df dy, or b by dy of minus 5xy cubed sine x plus y plus 15 xy squared cos x plus y. Okay, so another case where I'm going to have to use a product rule on both terms. So starting with the first term, so u, that's minus 5 xy cubed, dv dy, sine differentiates to cos x plus y. Next term, v, sine x plus y, du dy, that's going to be minus 15 xy squared. That's the first term differentiated. Now I need to differentiate the second term, 15xy squared cos x plus y. And again I use a product rule. So that's going to be u, 15xy squared, du dy, cos differentiates to minus sine x plus y, and then v, so that's cos x plus y, du dy rather, so that's going to be 30xy. And you see here I've got two terms I can combine. So my final answer is going to be minus 5xy cubed cos x plus y. Combining the two terms gives me 30 xy squared sine x plus y. And then the final term plus 30 xy cos x plus y. So we've now just got one cross derivative left to do, and that's d2f dx dy. So that's d by dx df dy, or d by dx of minus 5xy cubed sine x plus y plus 15 xy squared cos x plus y. And yet again, I'm going to have to use a product rule on both terms. So we start with the first term, minus 5xy cubed sine x plus y. So it's going to be u minus 5xy cubed dv dx, sine differentiates to cos x plus y. And then we have to do v du dx. So v is sine x plus y, and du dx is just minus 5y cubed. So that's the first term differentiated. Now we need to differentiate the second term, again using the product rule. So first of all, we keep the 15 xy squared, that's u, and then calculate dv dx. Cos differentiates to minus sine, that's minus sine x plus y. And then we do v, it's cos x plus y, du dx, that's just 15y squared. Now again, we can't tidy this up, but we can check this is the same as d2f dy dx. And in fact it is, just with the terms in different order. So we're finished.